you are fine, all everyone, and I hope you understand the previous lectures of econometrics, basic econometrics. Um, and it's my third lecture. The topic is two variable regression analysis, some basic ideas. The what is two variable regression and multiple regression? Two variable regression in which the dependent variable is related to single explanatory variable. But the multiple regression analysis in which the regressant is related one or more regressor, in many way a logical extension of the two variable case. Difference between conditional expected value and unconditional expected value. Conditional expected value as they depend on the given value of the conditioning variable x. Symbolically, we denote them as e y bar x, which is read as the expected value of y gives the value of x. Repeat this equation. Expected value of y given by the x. Expected value of y given by the x. Unconditional expected value is these conditional expected value from the unconditional expected value. For example, expected value is e y, the population. If we add the population and divided the number, it is called unconditional expected value. And this next topic is the concept of population regression function. It is clear that the conditional mean expected y given by the x is a function of x, where xi is a given value of x. This equation 2.2.1 expected e given by the x is equal to the function of x. Function of x denotes some function of explanatory variable of x. Is known as conditional expectation function or population regression function. Short form is PRF. In this equation, expected y given by the xi is equal to the beta 1 plus beta 2 xi. Beta 1 and beta 2 are unknown but fixed variables. Fixed parameters are known as a regression coefficient. And beta 1 is also known as intercept, and beta 2 is slope coefficient. Is also known as a linear regression function. The next topic, the meaning of the terms linear. The two topics is linearity in the variable and linearity in the parameter. Linearity in the variable, the first and perhaps more natural meaning of linearity in the is that conditional expectation of y is a linear of x. It is simple stat. What is y is linear of x, such as regression function expected y given by the x is equal to beta 1 plus beta 2 xi square. It is not a linear function because the variable x appear with a power. Next topic, linearity in the parameter. The second interpretation of linearity is that the conditional expectation of y, expected y given by the x, is a linear function of a parameter. The betas, it may or may not be linear in the variable of x. Expected y given by the x is equals to beta 1 plus beta 2 xi square. The next topic, the significance of the stochastic disturbance terms, vagueness of theory, unavailability of data, covariable versus the verifiable variable, intrinsic randomness in human behavior, poor proxy variable, principle of parsimony, and wrong functional form. Figures of theory. The theory, if any determination the behavior of y, v, p, or often is incomplete. Therefore, ui may be used as a substitute of all exclude or omitted variable from the model. Unavailability of the data. Even if we know what some of the excluded variables are, therefore consider a multiple regression rather than a simple regression. We may not have quantitative information about these variables. Core variable versus peripheral variable. Core variable versus peripheral variable. Consider the variable. It is quite possible that the joint influence of all may be more or less. One hopes that their combined effect can be treated as random variable. Intrinsic randomness in human behavior. There is bound to be some intrinsic randomness individual-wise that cannot be explained no matter how hard we try the disturbance. The UI may be very well reflect the intrinsic randomness. Poor proxy variable. Although the classical regression model assumes that the variable of y and x are measured accurately, in practice, the data may be plugged by error of measurement. Data on these variables are not directly observable or use proxy poor variable. Principal parsimony. We would like to keep our regression model as simple as possible. If we can explain the behavior of y with two or more explanatory variables, ui represent all other variables. We should not exclude relevant and important variable the regression model sample. Wrong functional form. Even if we have theoretically corrected variable phenomena, and even if we can obtain data on these variables, we do not know the form of the function relationship between the regressant and regressor. The next topic is sample regression function. The population of y value corresponding to the fixed x, we have deliberate avoid sampling consideration. Table 2.4, we can predict the average weekly consumption expenditure y in the population as a whole corresponding to the chosen. We may not able to estimate the PRF, probability regression function, population regression function, I think, accurately because of sampling fluctuations. Suppose we draw another random sample, table 25, from the population. This is diagram and table regression line based on two different samples. Explanation. The scattergrams two sample regression lines are drawn so as fit. SRF1, you see the diagram is based on the first sample and SRF2 is based on the second sample. We can absolutely show that either if the regression line represents the true population regression function, the regression line is known as the topic is sample regression function. The sample regression function SRF2 represents the regression line. The sample counterpart may be written as hat y hat is equals to beta 1 hat plus beta 2 hat xi. Equation 1. Y hat is equals to estimator of E expected of y given by the x. Beta hat 1 estimator of beta 1 and beta hat 2 estimator of beta 2. Estimators are also known as sample. A particular numerical value obtained by the estimator in application is known as estimator. This is very easy. We can express the SRF sample regression function in equation 1. Its stochastic form as follows: yi is equal to beta 1 head plus beta 2 head plus ui head, in addition to the sample already defined as ui head to net the residual. ui head is analog to ui and can be recorded as an estimate of ui. PRF stand for the population regression function is based on the sample regression function. This is the formula of PRF and SRF. This is the diagram of sample and population regression line. This is first line is SRF and the second line is PRF, and the table now is given below. You see this diagram. Explanation: for x is equals to xi, we have one example, and y is equals to y1i is the SRN. Now observe that is yi can be expressed as yi is equals to yi head plus ui head, and in term of PRF, yi is equals to expected y given by the x plus ui of yi head over the estimate the true expected y given by the x from the xi to the point left point of a SRFi is underestimated. The PRF stands for the population regression function. Thanks for watching this video.